Dear students, we start with chapter 3 of our practical work with a perforated disc. We are start entering the nodes. We start with 0, 0, 0, then with 0, 40, 140, and with 100, 0. Now we have all 4 points, and now we generate the surface using surface rules, and we are putting 2 nodes in and another 2 nodes. Okay, and put on create. Okay, and then we have the surface. And now we are going to put some nodes on the surface. We going to geometry, nodes, and then we use this interpolate nodes. And we are going to split interpolate a node here and a node here. It's always, if you press the middle mouse button, you acknowledge it. We are going out now. Now we are going to geometry, edit panel, surface edit, and trim with nodes. You go into the surface and select our node list with that one and that one, and go to trim, and now we have the 2 surfaces separated. Okay, now we're coming to the meshing. We are going to the auto mesh F12, and we are going to size and bias, and we are going to have quads with a size of 1 in the lower part. Sorry, we have to go to surface, that's the reason. Yeah, continue. Now it's fine, and now we're going to upper surface, and with a coarser mesh with 2, we mesh it. Okay, sorry. We have mixed. I'm going to delete it. F12, let's see. The size and bias. They flipped the setup. Now 1, acknowledge. We go into the return. Going to the second part, surface. Going to 2, mesh, fine, return, and now we have mesh generated. Now we are going to go to generate the loads and the collectors, everything. At the moment we just have our component. Now auto, we rename it and make it 2D. And now we're generating materials. We call it steel, and with a E modulus of 210,000 and a nu of 0.3, and we close it. We are going to make properties, create, and we call it P shell with a thickness of 1, and we are going to have the material connected to the steel, and now we are assign this to our property. Okay, we are putting different colors on our property so we can distinguish it. Let's make a little bit different one. So we are now looking component is different than property than this material, so everything is linked very well. So the next thing we have to do is the load collector create load collector. It's SBC and it's a single point constraint, and then we have collectors create. First we will make the SPC. We are going to boundary condition create constraint, click on this guy here and create all degree of freedoms, and we can also delete the temporary nodes. We go temp nodes, clear all. Now they are all out. What you see now, that boundary condition was linked with this temporary nodes. That's what normally happens if you have still temporary nodes, and we make a new new constraint on this point here, create, and stays. So we also want to have now a new collector boundary condition. Now we have a collector create load collector, and we rename it to load or force, and we are going to boundary condition create forces. Click on the right node. It should be a magnitude, I think, of 100, and let's create it. You can switch the to that, so we can really see it's created and it's pointing the right direction. And now we are going to solve it. So first we are going to save it, file, save as model, Chapter3 version 1, and now we're going to tools, analysis, obdestruct. Oh, do you see it here? Error, no load step defined. So we are going to set up, create load steps, and here we have to define the analysis type. It's linear static. We have to define the SPC, so our SPC, and we have to define our load, our force, and we can close that. We go to obdestruct, we save it, and it runs perfect. Okay, we go to the result button, we look at our results, and we want to see whether everything worked fine. We're going standard view, going to magnified factor of 1000, put this down, and now we are animating it, so you see it's moving in the upper half. We look at our displacement, and we can also see that. So now it's a big question why it's moving in the upper part, because the mesh in the upper part is show you the mesh. The mesh in the upper part is coarser than the mesh in the lower part, so this has a higher restriction against forces. So it's always with coarser meshes, and the finer meshes reacting better, or like in more accurate, and so this is stiffer than this side. So that's the reason we're going upwards. I will also show you the element stresses. Here you can see it's here the element stresses are lower because the coarser mesh also reacts like a filter. Okay, we are going to close this one here. No, we are not going to save it. Close, and now we are going to make the second part of the solution. Okay, first I'm going to return. I'm going to delete all my elements, and now we are going to split split the surface into 4 parts instead of being 2 parts. There are a lot of possibilities to split it. So let's go to geometry. I first generate a node in the middle of the surface, and I can Okay, I want to show you different ways to split now this surface. As an easy one, surface edit. I can go here on code node normal to edge. I go to the node and I go on the line, and then I have to go on the node again, then I go on the line. But there are also other ways to do it. I can do now untrim. For example, I can generate a line here. I go to nodes. I can go here on interpolate nodes, no, intersect maybe. Let's okay, you have to click it twice. Oh no, lines, intersect. Okay, yeah, and now I can generate middle nodes, and I can generate lines or line. And now for example, I can make the surface edit, trim with lines. I put my surface and the on, and then with a line. Oops. So you see multiple ways how to do it. You can try it out a little bit. You can also find, for example, what's described in your work papers in the PDF. You can go to F11 and you see all options you have a little bit in a shorter selection here. Okay, so now we are going to mesh just one part of it. It's suggested in your scripture, in your notes. We first I want to delete all temporary nodes. I'll make it clear all. Then I'm going to delete. You shouldn't delete it for your case, but I want to delete the surfaces I don't need. Go to surf. Okay, delete it, and I'm also going to delete the lines. I don't want to have lines. Oops, and go to return. Now we are ready to mesh this one. Going to F12 auto mesh, having again one and quads. Return, now it's meshed. So now I want to show a different way how to do it. We are going to put now our force on again. Create boundary condition, create forces, this guy here, and the same force like last time. But now we want to do something special. We are generating so-called symmetric boundary conditions. If we have a force in this direction, we want that these nodes here are able to move right, so in X direction. So we are going to make the SPC now, make current, and we are generating boundary conditions, constraint. You can go now into shift, and we have them all selected. So this is X. Let's first switch off all of them. So it should be able to move in X. So I don't want to constrain it in X direction, which is degree of freedom 1. But I want to constrain it in Y and in Z direction. So I generate that. And then I also want to go to this one here, and I want to constrain it in X direction because it shouldn't be able to move right, but it should be able to go in the Y direction, and I want to constrain the Z direction, so Now everything is set. Okay, I hope the load steps are still connected. Let's see whether it works. We're going to save model, no, save model as, but it's already overwritten the version, now it's version 2. And we're going to analyze this, op-destruct, okay, results. We're going to the axis, and now we are going to magnify it again, factor of 1000, and then we are going to apply the movement, and I have to check. Let's see. No, okay. I really have to look in my material now, because I'm worried I was flipping coordinate system somehow. Okay, this one is moving, so I have to check whether it's the right one. It should move. I look at the stresses, so they're just there. Okay, let's go down. So we have on the upper part of the y-axis, we have the forces being applied. I don't want to save the session. So you see now the reason I applied it on the wrong side. So it was applied on the upper part. I don't know when I was flipping my coordinate system, but it shouldn't distract you. It's always like this. If you open a new model, C is pointing upwards, so X, Y is like this, and I had it in a wrong orientation. Okay, file, open, let me see the model, version 2, and you see it was in the wrong direction. So that's the reason I wasn't set up the model in the right way. Okay, I will show you later how to look at the results, or let's just